In this video, we're going to look at converting from polar coordinates to Cartesian coordinates and sketching. So convert the following polar coordinates into Cartesian coordinates. So we're given the direct distance and the angle. Then we're going to try and transform this into XY coordinates. We can do this two ways, visually or algebraically. I prefer to do it algebraically, but you might prefer visually. We're just going to go through example A today in this video. So, for the algebraic, we need to know two little formulas. So recall that if I have polar coordinates r theta, this can represent Cartesian coordinates xy. So I'm just going to draw in this diagram and a right angle triangle. Notice that this is my right angle triangle, and I can develop two expressions, one for sine theta and one for cos theta. So for this coordinate point, recall that sine theta equals opposite over hypotenuse, or y over r. Cos theta adjacent over hypotenuse, that will give me x over r. By subbing r and theta into them to find my x and y coordinates. Okay, let's have a go. For A, I know the polar coordinates are root 2, comma, pi on 4. We're going to change this to Cartesian. So r is given by root 2, and pi on 4 is equal to theta. So we can say sine theta, or sine pi on 4, is equal to y, that's what I'm trying to find, over r, where r we said was square root of 2. Again, cos, we can do the same. So we have cos pi on 4 is equal to x, what I'm trying to find, over root 2. Now all I have to do is rearrange both equations to make y and x the subject, and then I'll be able to determine what x and y are. So times the root 2 up, and for y we'll have the square root of 2 times sine pi on 4. Now I know that sine pi on 4 is 1 on root 2. So I'll have that y equals root 2 times 1 on root 2. Similarly for cos, I know that cos pi on 4 is again 1 on root 2. So I'll have that x equals root 2 times 1 on root 2. Cancel out the root 2's, I get x equals 1, y equals 1. So my Cartesian coordinate of the point root 2 pi on 4 is equal to 1, 1. Visually is a pretty similar method, but it's better if you don't like formulas. So this is what you do. You simply plot the polar coordinate that you were given, filling in the angle and your distance r. Then use your identity triangles. So for instance, I know one identity triangle that has an angle of pi on 4. That identity triangle or unit triangle looks like this. Pi on 4, I have 1 over root 2 and 1 over root 2 as my opposite and adjacent sides, and my hypotenuse is 1. Notice that I need that hypotenuse length to be root 2 if it's going to match my polar coordinates up the top. Using similar triangles, I'm going to multiply all the side lengths by root 2 so that my hypotenuse becomes root 2. The angles inside the triangle will stay the same, and if I multiply all sides by root 2, I actually end up with my opposite and adjacent sides equaling to 1. That gives me my x and y coordinates being 1 across the bottom and 1 vertically up. So I have x and y equals 1, 1. The last thing you need to know is how to plot polar coordinates. You just need to identify what r is and what theta is, and then put your point in the appropriate quadrant. So for the point root 2 pi on 4, start with your angle. I know that angle is pi on 4 units. in the anti-clockwise direction, and my r is √2. That means my point will be in quadrant 1, approximately here. It doesn't have to be too accurate. Now, the second point for A is minus √2 pi on 4. This is where that negative r comes into play. Whenever you see a negative r, that means you flip the point over the origin. Because this has the same absolute value of r and the same theta, what we do is we go pi on 4 units up, √2 units long, but then we flip it across the origin. So this point has the same length, okay, but it's flipped into quadrant 3. This is the point minus √2, comma, pi on 4. For B, I have the point 4 and minus 2 pi. Start with the angle. If you go minus 2 pi around, so we go clockwise direction all the way back to my positive x-axis. If they then go 4 units along in the same direction, I'm going to end up somewhere here. That's my first point. The second point is minus 4, 2 pi. A little different. Again, start with the angle. We're going to go around this time in the anti-clockwise direction, 2 pi radians. Again, I'm going to end up back at the positive x-axis. But that minus 4 means that I'm going to go 4 units along the positive x-axis, then flip it over the origin. So I'll actually end up at the negative x-axis 4 units along. This is the point minus 4, 2 pi. Lastly, I have 2 more polar coordinates. So if we have the point 2, 4 pi on 3, again, start with the angle. We're going to go 4 pi on 3 around. Remember to go anti-clockwise. I'll end up in quadrant 3. Recall that 4 pi on 3 is 3 pi on 3 plus pi on 3, or pi plus pi on 3. That's how I know I'm in the third quadrant. My length to that point is 2 units, completely not to scale. So it is approximately here in quadrant 3. The next point, the angle is pi on 3 units. So I go pi on 3 units. I'm in quadrant 1. The length is 2, but remember it's negative. So I'm again going to flip this right over the origin, and I actually get that both of these points are the same. So there are 2 ways to represent this point. 2, 4 pi on 3 is the same as minus 2 pi on 3 in polar coordinates. And I hope you appreciate the fact that these are polar bears, no pun intended.